So good evening, one and everybody. So in the prior sessions, we just got discussed about the introduction to this HVAC and to the MEP, isn't it? That's what we pursued in the last session. So today we will be grounded onto something very related to this ventilation sites. Okay, I hope we almost completed the heating aspects, isn't it? Such as to be the definition of heat and respectively the methods that we need to implement for the heating methods and correspondingly the types of heat and heat transfer processes. So today we will be digging upon into something new which is named as ventilation. Okay, basically the purpose of ventilation is to remove the stale air and replace the existing air with fresh air. Okay, so the concept is very clear here. Inside a room, if I'm confronting some persons, or for example, like I'm filling 10 to more than persons in a small room, and in that room I'm not providing any kind of fans, no windows, and I'm completely closed them right inside the room. What will happen eventually? As a humans, we started to sweat, and uh, deliberately there should be a like what we can say, foul smell will be there due to the sweat, isn't it? And respectively there will not be enough amount of oxygen required for the breathing, isn't it? So this is the key points that we must need to consider while doing a ventilation process. Okay, so is it clear? Basically ventilation meant to be, it is the process of removing the stale air. So stale air means it is nothing but these air which contain some kind of pollutants, foul smells. So these whole kind of airs are termed as to be stale air itself. So typically from this room, we will be eliminating this stale air by replacing it with the fresh air. So what do you mean by a fresh air? Fresh air is nothing but it is meant to be some outside air. That's it. Okay. Fresh air meant to be the outside air itself. So typically you are replacing the existing air with the fresh air from the outside itself. So there are two kind of ventilation approaches are there. The first one should be positive ventilation. What is it? Positive ventilation. So positive ventilation, which implies here with the help of a fan, you will be allowing the fresh air directly into the rooms. Okay, am I clear? Once again, guys, here in the case of positive ventilation, with the help of some certain fans or some kind of blowers, we will be uh, admissioning this kind of fresh air directly from outside, then to the rooms. So exceptionally here, once this fresh air is filled right inside the existing area, what will happen? Eventually the exhaust air, which is meant to be the stale air, should be pushed outwards, isn't it? So this is how an positive ventilation works. Is it clear, guys? So fair enough. This is the concept of positive ventilation. So satisfactorily, whether in the case of negative ventilation, it is like vice versa, which means with the help of a same fan or blowers, we will be removing the existing air or the exhaust air directly from the rooms. Am I clear? With the help of a fan, we will be fully removing the existing stale air right from the area to the atmosphere itself. So now this area will become a low pressure, isn't it? Because we confrontally pushed the entire existing air from those area, resulting in the formation of low pressure. So once the low pressure is achieved right there itself, the atmospheric air will balance out. That means eventually the fresh air from the outside will be entered right inside to those areas itself. So this is meant to be negative ventilation. Is it clear? Is it clear, guys? Okay. Hello. Am I clear?
Can you able to repeat the negative ventilations?
Negative ventilation. Okay, fine. Once again, negative ventilation is typically meant to be removing the stale air with the help of a fan. Here, there is no admission of fresh air directly. Okay. Here, we will be forcefully exiting the existing air right from the area with the help of some kind of fans. So eventually, what will happen? Those area will become the low pressure. So in order to balance out, the atmospheric air will be automatically infiltrated right to those areas itself. So that is meant to be negative ventilation. For example, we can say in the case of positive ventilation, the best example that I can provide you is the air conditioning process. In air conditioning process, we are admissioning those fresh air directly from the outside itself. Whereas in the case of sorry, go on. Is there any doubts? Like anything to ask? Okay, I hope so. Whatever. So here, in the case of negative ventilation, with the help of a fan, it should be forcefully rejected from the room itself. That's it. So once it's done, the area will become low pressure and conveniently the atmospheric air will be balancing out. That's it. The examples for negative ventilation, we can say it has to be this one, which means, okay, once again, yeah, factory ventilation. Okay, factory ventilation, and similarly basement ventilation, toilet ventilation, kitchen ventilation. So these whole things are meant to be the negative ventilation itself. So once again, I will be going over through this each and every topics detailedly at a certain stage itself. So till now, it's just to be an introduction. That's it. Okay. Generally, I told you yesterday about some kind of standards that we are following, isn't it? So what are the standards that we can see? The first one is ASHRAE and ISHRAE. ASHRAE meant to be American Society of Heating, Refrigeration and Air Conditioning Engineers, whereas ISHRAE stands for Indian Society. That's it. Then NBCI means to be National Building Code. Then you can see a lot of codes are there. Among this one, this NFPA and FSI. This is meant to be the Fire and Safety Association. And similarly, these are the codes that we will be following for firefighting installations. Clear? And the other one is ASME, which is American Society of Mechanical Engineers. Okay. Then ANSI, that is American National Standard of Institution. Then BS, which is a British standard. UL is meant to be Underwriters Laboratory, and FM means to be Factory Mutual. So this UL, FM, it's very important to deliberately, like it's kind of an approval. Okay. So these both BS and UL are something like an NGO, like a non-governmental organization, and it's a non-profitable organization once again. So, but preferentially, if you are manufacturing some kind of things, so you must need to get approval from this both guys, which means from UL and FM itself. Then only you can implement these materials or equipments that you've been created or manufactured right onto the firms or right onto the sectors itself. That's it. Then SMACNA, Sheet Metal Manufacturers and Associations, and Air Conditioning Contractors of Northern America, or National Association, either you can call. Then IPC, UPC. So these things that I already explained in the last session itself, isn't it? That's it. So whatever, this is all about the ventilation topic. So while we studying about ventilation, you also need to aware about the ventilation aspects. For example, here, in the case of while studying about the codes, preferentially, we must need to follow the ASHRAE 62 and 61 code for ventilation. Okay, that means inside the ASHRAE 61 and 62, they preferentially been explained about the ventilation aspects. That means how you need to install the ventilation systems inside a building. And for negative ventilation and positive ventilation, what are the aspects? So these things can be encountered right inside these ASHRAE codes itself. All right. Is it clear? Is it clear though? For negative ventilation, there is no any input of air by any instrument. No, there is no any input. So here, I think Badusha, isn't that that question is asked? Hello, am I audible, Badusha? Okay. Fine. Here, actually, you don't need any kind of things. So this is very simple, ma. For example, in a negative ventilation, yeah, take this toilet. Inside this toilets, you can see some gaps, isn't it? So what are this? What are the preference of these gaps? This is meant to be the infiltration. Okay, that means from the outside through the bottom gaps of your doors, the outside air will be getting entered once the existing air is replaced or existing air is pushed out to the atmosphere itself. Okay, so that's how this infiltration happens right inside a negative ventilation side itself. Is it okay? புரிஞ்சுதா உங்களுக்கு இப்போ?
Yes, sir. Yes, sir.
உங்க
Yeah,
வாய்ஸ்
for it.
பிரேக் ஆகுது. Okay, fine. Okay, that's it. Okay, is there any doubts, guys? No, isn't it? Is the ventilation is clear? I told you guys this is just a uh, intro for the ventilation itself. We are not digging up too far. So I hope this ventilation is clear. Okay. Any doubts? ആർക്കെങ്കിലും ഡൗട്ട് ഉണ്ടോ? ഡൗട്ട്സ് എടുക്കാം உங்களுக்கு யாருக்காவது? இல்லல்ல? Okay தானே? Okay, whatever. Next of all, we are going to jump over to air conditioning. Okay. So before going into air conditioning, first of all, tell me, what do you mean by air conditioning? Tell me, guys, what do you mean by air conditioning? I think you've been must walked on this phones, some of you guys, isn't it? So tell me, what do you mean by air conditioning? No idea. Hello? Are you there? Anyone? Hello, Sachin and Shahul and Shafiq. Come on, guys. What do you mean by air conditioning? Okay, I will answer. Someone is okay.
Yeah.
Human comfort. But I'm asking about not the
Yeah, it removes heat
objective.
from a particular room
Okay.
and
Yeah,
provide an optimum temperature for the occupants.
exactly. So you can tell like that. So basically, air conditioning refers to it may can either heat or cools. Okay, it may can either heat or cools the surroundings at the same time. It needs to freshens the air and maintain the purity of air. And symbolically, it must need to control the humidity right inside the air door itself. So once it's done, the entirely should be termed as to be an air conditioning process. Clear? So that's why these are the basic indices that we need to must learn while studying about air conditioning. Okay? Clear? So the first one is temperature. So yesterday I already mentioned the basic human comfort temperature. What is the basic human comfort temperature, guys? Tell me.
22 to 26.
Yeah, 22 to 26 degrees Celsius itself. So basically, for a human comfort, the basic temperature range should be lies between 22 degrees Celsius to 26 degrees Celsius something. That's it. Okay. So it's both for heating and cooling itself, which means if the ambient temperature is much greater than the comfort temperature, you must need to do the cooling process. Whereas if the ambient temperature is much lesser than the comfort temperature, you might need to do this heating process. So that's the difference between these both. But however, it should be simply said it has to be an air conditioning process itself. Then, next of all, it's about the humidity. So what do you mean by humidity? So we will learn this humidity later inside our psychrometric classes itself. So now I'm just simply implying that it has to be humidity means moisture content right inside the air. That's it. Okay. Humidity means moisture content right inside the air itself. Then the other one is odor controlling, oxygen level maintaining, air velocity, air distribution, air purity. So these are the basic elements of air conditioning right now itself. So I told you guys, for the best temperature, it should be 20 to 26.5 degrees Celsius itself. Whereas the best relative humidity, which is meant to be the humidity range, should be lies between 40 to 60%. So that's the range. Then these are the filters we will be using in order to purify the air which will be getting entered into your equipment itself, or sorry, to the rooms itself. So the first one is mentioned as to be pre-filter. This is also called as 10 micron pre-filter. What is it? 10 micron pre-filter. Actually, these pre-filters and these fine filters are typically implemented for normal application. That means this kind of commercial areas, residential applications. So in those areas, we can either use a pre-filter or fine filter. So I will explain where we will be preferentially using these both filters differently. Okay. Pre-filters will be fitted along within the these high wall ACs, cassette AC, something like that itself. And fine filters should be preferentially provided for something like DSA, ductable split AC, vertical units, something like that. Okay. So fine filter is also called as to be bag filter, and the thickness value is around like 5 micron, so lesser than it. So the filtration rate should be comparatively higher than that of the pre-filter right here itself. So as I mentioned before, this pre-filter and fine filter both are implemented for normal air conditioning application itself. But we must need to know we having rather than this normal application, you also need to provide air conditioning for other applications. For example, it's like clean room condition. So what do you mean by clean room conditions? It's like in hospital areas or like OP theaters, then pharmaceutical industries. So generally, this HEPA filters are defined or HEPA filters are implemented typically in operation theaters, which means those machines should be connected along to the operation theaters. So they will place this kind of HEPA filter right on the machine, which should be connected along with the operation theaters or the hospital areas itself. Okay, so HEPA stands for high efficiency particulate arrestor or air filter, either you can call it. And here the filtration rate is claimed as to be 99.97% of filtration. And once again, these filters can sieve out, I think, nearly 0.3421 submicron particles of diameter. Okay, that means the filtration is very, very high. That's it. From the compared to normal filters. And the other one is ULPA filter. ULPA stands for ultra low penetrant air filter itself. So ULPAs are generally used in pharmaceutical industries. Where is it? Pharmaceutical industries. Here, the air filtration rate should be around like 99.99% of air filtration. So even these filters can capture up to 0.1 submicron particle diameters. Sorry, 0.1 diameter submicron particles. That's it. So these are the different kind of air filters. So I hope it's clear. All right, guys. Next of all, it's about this point, which is meant to be order control. So typically, order control is an optional thing. That means either you can provide it or you don't have to do this thing mandatorily in each and every projects. So order masking is nothing but, guys, we are like what we can say. It's a mission actually. This mission is or an equipment which is named as to be Ecosen mission or aroma scenting missions. In shopping complexes or in airports, while you are entering to those airports, you can feel a pleasant smell, isn't it? Actually, in there, they will be providing some kind of uh, fragrance along with the air, which should be centered out through those ducts and to the diffusers itself. Okay. In our homes, we will be simply using this kind of air wicks, air wick. You've been heard about this term, isn't it? That means an automatic air wick. In certain intervals, it will spray automatically to your rooms itself in order to maintain the smells or the fragrances right inside the area. Preferentially, the same thing here also. Along with the duct system, it should be connected. So at a periodic intervals, it will spray some kind of fragrance along with the ductwork itself. So is it clear? So it's not a mandatory thing, guys. Once again, it's an optional thing. Then next of all, it's about air distribution. So basically, air distribution prefers for duct system. Okay, air distribution prefers for duct system, and these duct systems should be in a different types, different kinds, different materials. So we will be learning these kind of duct system in the upcoming sessions, and correspondingly, I told you we need to maintain the oxygen quantity. For that one, we must need an fresh air outlet. Sorry, fresh air inlet. Okay, a fresh air inlet should be taken out from each and every it should be distributed across the each and every area where you will be providing the air conditioning. That's it. Next of all, it's about the air velocity. So generally, air velocity is maintained in the ducts in order to provide the enough amount of air which should be uh, allowed right inside those ducts itself according to the flow rates. So that's why we will be using this equation termed as to be continuity equation. I think you've been studied this continuity equation in your engineering side itself, isn't it? Q equal to A into V. So Q means to be flow rate, and A means to be the area, and V means to be the velocities. That's it. So these are the basic elements of air conditioning. Is the air conditioning is clear? Is this topic is clear? Yeah, exactly. Okay. So
Actually, one question, Akshay. Like
tell me,
when
tell
it
me.
comes to temperature, you compared it against the ambient temperature, whereas for relative humidity, you mentioned 40 percentage to 60
60%.
percentage. Yeah. So how does it affect or have a role during hot climate and cool climate?
So that's it. I will explain those one while we are studying about psychrometry. Okay, I told you now. It's
Okay.
just a beginning class. That's it.
Okay.
Or we
Okay.
will be going to dig upon that thing in the later classes itself. Okay. All right. Because we all been fresh, isn't it? So we must need to get over with the basic things and then to the deeper things. Okay.
Yeah.
It's very simple, yeah. It's meant to be some kind of humidity ratio. So while you studied about humidity ratio, then you can eventually understand the relative humidity. So and then how this
Velocity for
affects
air,
on this area. Yeah, go on.
velocity for air is same as density for water, right?
Yeah, exactly. Here, yeah. That
Just
means fluids. What do you mean by fluids? Fluids can be either liquid or gas.
Liquid or gas.
Exactly.
okay.
So for both things, the aspects are different. For liquids, we will need to
Yeah.
consider the densities, isn't it? Whereas in the case of
Yes.
air, we must need to aware about those preferentially, as you said, that's about the velocities itself. Okay,
Velocity.
that's it.
Oh.
Then in fluids, you almost consider one more point, which is viscosity, isn't it? So these things can be learned in the upcoming sessions itself. Okay.
Okay.
So is the basic studies clear, which means the air conditioning studies clear? Okay. I hope is it clear. Then what about this? Shamir Manslayo? Like Shamir Ali? No. Yeah. Okay, fine. Yeah, continuity equation again. Yeah, you don't need to worry about that, yeah. Like continuity equation, we will be going to again do the same thing while duct sizing. Okay, so actually this continuity equations meant to be uh in order to know the flow rates according to the area and velocity. Q stands for flow rate, A stands for velocity. Sorry, A stands for area and V stands for velocity. That's it. Okay, so these things are used in order to size the ducts properly. That's it. That's why we are using this continuity equation. And this continuity equation is much more similar to the fluids also. In water, you've been already studied this. Okay, and that's it. Next of all, we are going to refrigeration. So tell me, guys, what do you mean by refrigeration? Any idea? What do you mean by refrigeration? All right, I will explain. So tell me, what is the purpose of refrigeration? அதாவது தெரிஞ்சிருக்கணும்ல சொல்லுங்க, what is the purpose of refrigeration? Tell me, anyone can answer.
Keep things cool.
Force of air increase, there must be production of heat. Force of air increase, force of air. Actually, Badusha, this force of air increase, there must be production of heat or not. No. We need to study not about the force, it's about the pressure. Okay, so these pressure and these kind of things should be learned in the upcoming session. Okay, now I told you these are very basic things I'm taking right now itself. Okay, Badusha, fine. So ஃபோர்ஸ் வந்து ஃபோர்ஸுக்கும் ஹீட் ப்ரொடக்ஷனுக்கும் ஒரு சம்பந்தமும் கிடையாது. ஓகேங்களா? பாதுஷா இஸ் மலையாளி ஒரு தமிழ்? தமிழ் isn't it?
Tamil, sir. Tamil.
ஓகே பாதுஷா. ஆக்சுவலா ஃபோர்ஸுக்கும் ஏரோடைய ஹீட் ப்ரொடக்ஷனுக்கும் ஏர்ல இருக்கிற ஹீட் ப்ரொடக்ஷனுக்கும் ஒரு சம்பந்தமும் கிடையாது. ஓகேங்களா? So it's bit different actually. All right. So once you will learn this, guys. Okay. So I hope this one is clear. Then yeah. Tell me, guys, both yet? Yeah, refrigeration. So what is the purpose of refrigeration? Come on, guys. What is the purpose of refrigeration? Is my question is clear? எதுக்காக refrigeration பண்றோம்?
For
For
cooling.
what purpose? For
To keep
Cooling.
things cool.
to preserve food items. That's it. Isn't it? to preserve food items or something else at an optimum temperature, isn't it? Same as per air conditioning itself, right? But here, that is the purpose. But now, while he's studying about the working principle, it's a bit different. Actually, this refrigeration is found out, or it should be introduced by uh, William Currens. Actually, he's an Scottish doctor. I think in 1720s or something, he just found out that evaporation causes some kind of cooling effect. So that's how he find out the refrigeration. And this event, these refrigeration and the related things are grown eventually. It's not found out by a single or a uh, single scientist itself. Like a lot of people or a lot of scientists been worked on that thing itself in order to get a proper outcome. So it's an years of study actually. All right. So here, while we studying about this one, I think in 1720s, yeah, William Cullen. That's how he just obtained the idea of refrigeration. So basically, in simpler words, I will explain the working principle of a refrigeration. A refrigeration is a process where or we can say here, the heat should be transferred from low temperature region to high temperature region with the help of some external works. Okay. So refrigeration is a process where low temperature, or we can simply say the heat transfer will be resulting, or the heat transfer from low temperature region to high temperature region with the help of some external works. Am I clear? Is it clear, guys? Once again, refrigeration means it is a process of heat transfer where is a process of heat transfer from low temperature region to high temperature region with the help of some external works. So is it possible? Tell me, guys. Can I, once again, is the heat transfer from a low temperature region to high temperature region, is it possible naturally? Tell me, guys. Hello? Is my question is clear? Yeah.
If
It's possible.
No, your voice is breaking
No.
here.
It is possible.
Which is possible.
No, it is not possible.
Heat transfer is possible.
I'm asking whether the, the whether the heat should be transferred from low temperature region to high temperature region. Is it possible or not?
No, it is not
As
possible.
naturally,
Unless
as naturally.
it's not.
I'm once again I'm implying the point naturally. No, no.
Naturally, it's not possible.
Not possible. That's what I'm asking. So basically, for heat transfer, it's always work with the natural idea, which is always heat should be transferred from high temperature body to, or high temperature region to low temperature region. That's what you studied in your thermodynamic studies, isn't it? So for that one, you must been studied a lot of laws, something like Gauss law or something like a law of thermodynamics, zeroth law, first law of thermodynamics. A lot of stuff you've been studied, isn't it? So here, a natural heat transfer is possible, whether it's from high temperature to low temperature, isn't it? That's why inside this refrigeration, we are saying with the help of some external work. So those external work meant to be the refrigeration. Clear? So here, the heat transfer is possible when you provide some kind of external work. Clear? That's how this refrigeration takes place. For example, what is an example of refrigeration process? Tell me, guys, what is the example for refrigeration process? Refrigerator, isn't it? Fridge. That's how you call this one. So, can you tell me that inside the fridge, or while you consider those fridge, which should be the low temperature region, and how this fridge actually works? For example, typically we will say the fridge, that means the freezer and the inside area should be considered as to be the high temperature region, and the surroundings of the fridge should be termed as the low temperature region. So what we are actually doing right here itself, we are removing the heat right from the high temperature region by continuously providing the low temperature, or the heat should be transferred to the high temperature region from a low temperature region itself. That's how you are maintaining the temperature right there itself. Have you ever seen when your fridge is cooled, will you turn that off? No, isn't it? Because it still need to run. If you turned off the fridge, what will happen? The heat transfer process will stop right there itself. Am I right? So that's how this refrigeration works. Clear? Okay അല്ലേ? മനസ്സിലായി? ഞാൻ പറഞ്ഞ മനസ്സിലാവുന്നുണ്ടോ? ഹലോ മലയാളീസ്, നമ്മുടെ അതിൽ ആരും മലയാളം മനസ്സിലായില്ല കറക്റ്റായി. ഓക്കെ, മനസ്സിലാവുന്നില്ലേ നിങ്ങൾക്ക് ഞാൻ പറഞ്ഞത്? உங்களுக்கு புரியுதில்ல? Yeah, okay, fine. All right, guys. So this is all about the refrigeration itself. Yeah, this is the thing that I'm showing. So generally, for once again, typically, are you asking about ഷമീറെ ഫ്രിഡ്ജിനെ കുറിച്ചാണ് ചോദിക്കുന്നത്? ഫ്രിഡ്ജിനെ കുറിച്ചാണ് എക്സ്പ്ലെയിൻ ചെയ്യേണ്ടത് ആണെങ്കിൽ ഞാൻ ഫ്രിഡ്ജിന് ഓക്കെ, ഒന്നുമില്ല. നമ്മൾ ഫ്രിഡ്ജിൽ നമ്മൾ എന്താ ചെയ്യുന്നത്? ശരിക്കും പറഞ്ഞാൽ ഫ്രിഡ്ജ് എന്ന് പറയുന്നത് നമ്മള് ഫുഡ് ഐറ്റംസ് പ്രിസർവ് ചെയ്യാൻ വെച്ചിരിക്കുന്നതാണ്. സോ വൺസ് അവിടെ നമ്മൾ എന്ത് ചെയ്യുന്നത്, ആ ഫ്രിഡ്ജാണ് ശരിക്കും നമ്മുടെ ഹൈ ടെമ്പറേച്ചർ റീജിയൻ എന്ന് പറയുന്നത്. നമ്മൾ പുറത്തീത്തെ ഹീറ്റ് എടുത്തിട്ടാണ്, വിച്ച് മീൻസ് ഹീറ്റ് എന്ന് വെച്ച് കഴിഞ്ഞാൽ കോൾഡ് അല്ല, സോറി ഹോട്ട് അല്ല കേട്ടോ, ലൈക്ക് ഹീറ്റ് എന്ന് വെച്ച് കഴിഞ്ഞാൽ എനർജിയാണ്. സോ അത് ഇതൊരു കോൾഡ് ആവാം ഹോട്ട് ആവാം. സോ ഇതൊരു വർക്കിംഗ് മൂല്യമാണ് നമ്മളത് ഉണ്ടാക്കുന്നത് ശരിക്കും. സോ പുറത്തിരിക്കുന്ന ടെമ്പറേച്ചർ എപ്പോഴും നമ്മുടെ ഇന്നർ ടെമ്പറേച്ചറിനേക്കാളും കുറവായിരിക്കും. അതുകൊണ്ടാണ് നമ്മൾ ലോ ടെമ്പറേച്ചർ എന്ന് പറയുന്നത്, പുറത്തുള്ള ആ സ്ഥലത്തിന്, വിച്ച് മീൻസ് സറൗണ്ടിങ്സ്. സോ ഇവിടെ നിന്നാണ് നമ്മൾ ഹീറ്റ് ട്രാൻസ്ഫർ ചെയ്തുകൊണ്ടേയിരിക്കും. എങ്ങോട്ട്? ഫ്രിഡ്ജിന്റെ അകത്തോട്ട്. എന്നാലല്ലേ ഫ്രിഡ്ജിന്റെ അകത്തു നിന്നുള്ള ഹീറ്റിനെ നമുക്ക് റിമൂവ് ചെയ്യാൻ പറ്റത്തുള്ളൂ. അവിടെ ഹീറ്റ് റിമൂവൽ നടന്നാലേ നമ്മൾ ഉദ്ദേശിച്ച ആ ടെമ്പറേച്ചറിലോട്ട് അത് എത്തത്തുള്ളൂ, അവിടുത്തെ ടെമ്പറേച്ചർ അല്ലേ. അപ്പം ആ ടെമ്പറേച്ചർ എത്തുന്നവരെ നമ്മളവിടെ ഹീറ്റ് ട്രാൻസ്ഫർ ചെയ്തുകൊണ്ടിരിക്കും. അവിടെ ടെമ്പറേച്ചർ എത്തിയാൽ പോലും നമ്മൾ എന്ത് ചെയ്യും? ചെയ്തുകൊണ്ടേയിരിക്കണം, റിമൂവ് ചെയ്തുകൊണ്ടേയിരിക്കണം. നിങ്ങൾ ഫ്രിഡ്ജ് ഓഫ്, ലൈക്ക് ഇപ്പം ഫ്രിഡ്ജ് ആ ഒരു സെറ്റ് പോയിന്റ്സ് എത്തി ഉള്ളിൽ കൂളായി എന്ന് പറഞ്ഞിട്ട് നമ്മൾ ആരും ഫ്രിഡ്ജ് ഓഫ് ചെയ്തിടാറില്ല, ഇല്ലല്ലോ. എന്ത് പറ്റും? ഫ്രിഡ്ജ് ഓഫ് ചെയ്തിട്ട് കഴിഞ്ഞാൽ വീണ്ടും അതെന്താകും? അകത്തിരിക്കുന്ന എല്ലാം കൂടി ഹീറ്റ് ആവാൻ ആരംഭിക്കും അല്ലേ. സോ ഇതാണ് ഇതിനോടത്തെ ഐഡിയ. ശരിക്കും പറഞ്ഞാൽ ഇവിടെ നിന്ന് നമ്മൾ എന്ത് ചെയ്യുന്നു? ആ ലോ ടെമ്പറേച്ചർ റീജിയനിൽ നിന്ന് ഹൈ ടെമ്പറേച്ചർ റീജിയനിലോട്ട് ഹീറ്റ് കണ്ടിന്യൂസ്ലി ട്രാൻസ്ഫർ ചെയ്തുകൊണ്ടിരിക്കണം. ഇത് ചെയ്യാനായിട്ട് നമുക്ക് എന്ത് വേണം? ഒരു വർക്ക്, ഒരു എക്സ്റ്റേണൽ വർക്ക് അല്ലെങ്കിൽ എക്സ്റ്റേണൽ ഫോഴ്സ് നമുക്ക് ആവശ്യം വരും. അതാണ് നമ്മൾ ഇവിടെ കൊടുക്കുന്നത്. അതിന്റെ പേരാണ് ഈ റെഫ്രിജറേഷൻ എന്ന് പറയുന്നത്. മനസ്സിലായോ ഷഫീഖെ? ഷമീർ അല്ലേ? സോറി, ഷമീർ. ക്ലിയർ അല്ലേ? മനസ്സിലായെന്ന് തോന്നുന്നു. ഓക്കെ, ഫൈൻ. All right. So that's it, guys. So in refrigeration, now I told you about the working principle, isn't it? But actually, these refrigerations are represented in some kind of cycles. Okay. So cycles mean to be what? Cycles symbolically represent it should be starting from a base point and it should be ended up right inside the same point itself. Then only you should be calling it as to be a cycle, isn't it? So here also, we will be implying this working principle in certain cycles. So the first one is Bell-Coleman cycle. Then the other one is reversed Brayton cycle, VAR cycle, VCR cycle. So I hope you've been studied this kind of things, isn't it? Refrigeration cycles, especially VCR cycle and VAR cycle. Your thermodynamics, you've been studied related with some kind of PV diagrams, TS diagrams, isn't it? PV means what? Pressure volume diagram. TS means temperature and entropy. S stands for entropy, isn't it? Temperature and entropy diagrams, isn't it? No, whatever. I don't know, guys. Actually, you are remembering or not. So these are the things that you already studied in your engineering side itself. All right. So, however, this much refrigeration cycles are among us, but still the widely used refrigeration cycles are both VCR and VAR. Among this VCR and VAR, VCR is the most used. Okay, that's the difference. Clear, guys? Okay, Len. All right. Now, I would like to explain some kind of basic things, which means basic rules. Come on, tell me, guys. You've been studied about gas law, isn't it? Can anyone say any gas laws that you studied? Ma'am, you can say anything, like any gas laws. Have you ever remembered? Others, Shafiq, ஏதாவது ஞாபகம் இருக்கா? Any gas laws?
So now the MBA
Electrical.
background, finance and
Okay. Fine.
marketing.
Sorry.
Because
But
I worked,
however,
I want to study more. Oh,
you studied 12th standard, isn't it?
yes.
Then what, yaar?
Yes.
Tell me.
Adli
12th
commerce.
Are you? Okay, fine. Sorry.
Maybe before 12th, என்னன்னு தெரியும்.
Okay, fine. Just leave it to. So tell me, guys, the other guys who completed engineering or 12th science, anything, you've been studied this kind of gas laws. Come on, guys, tell me. ഓർമ്മ ഇല്ലേ ആർക്കും? Shivaprakash, any idea? Actually, okay, not a problem. Okay, all right, guys, I will explain. So you've been studied a lot of gas laws. The first one should be the Boyle's law, Charles' law, Avogadro's law, then universal gas law, isn't it? The first the basic thing is pressure proportional to temperature, isn't it? Have you remember these points? Pressure proportional to temperature. That means what? If the pressure increases, gradually the temperature also increases. Why? Because the pressure is dependent to temperature itself. Am I clear? Okay. Is it clear, guys? So the first point, it's very important, guys, because later we are going to study about the refrigerants. So for that one, we must need to know about the basic laws. So this is the gas laws that we need to understand. Okay. So pressure proportional to temperature. And in Charles' law, it's like pressure inversely proportional to volume, isn't it? It's something like P1 T1 P1 V1 equal to P2 V2. Then all gas, like the combination gas law should be like P1 V1 by T1 is equal to P2 V2 by T2, isn't it? Remember? Formula, okay? Yeah, did you remember? Okay, so these are the basic gas laws. So once again, pressure inversely proportional to volume, which means if the volume is high, that means there should be less pressure. If the volume is too low, that means the pressure should be too high. That's it. The vice versa. So you know the basic difference between directly proportion and inversely proportion, isn't it? Once again, guys, pressure proportional to volumes. Pressure proportional to temperature. Pressure proportional to temperature, not temperature proportional to pressure. That means pressure increases, temperature increases. But if the temperature increases, doesn't mean that pressure will increase. Clear? All right. Is it clear now, Shafiq? Okay.
So it's very clear. Actually, forgotten.
That's it. I remember because it should be already completed in 10th standard or something. I hope so.
Yes.
Yeah, that's it.
Yes.
So this is the very basic law. That's it. So pressure proportional to temperature and pressure inversely proportional to volume. So conveniently, these laws in your 11th standard, 12th standard, you've been much more elongated this equation, something like PV is equal to MRT, which is mass into universal gas constant into temperature, isn't it? Then conveniently you must be read to this one like PV is equal to CP CP by CV is equal to gamma, isn't it? Specific heat at a constant pressure and specific heat at constant volume is equal to gamma. So a lot of things, whatever, just I'll leave it to guys. So here, this is the basic idea: pressure proportional to temperature and pressure inversely proportional to volume. That's it. Next of all, one more thing. I think it should be a bit new for you. Pressure directly proportional to boiling point. So what's that mean? Pressure directly proportional to boiling point. What's that mean, guys? Tell me. இவ்வளவு நேரம் எக்ஸ்பிளைன் பண்ண வச்சு சொல்லுங்க. என்னதா இருக்கும்? Pressure directly proportional to boiling point ன்னு சொன்னா என்னவா இருக்கும்? Come on, guys.
If pressure increases, boiling point will also increase.
Exactly. If the pressure is high, the boiling point is also high. Can you tell me the boiling point of water?
100 degrees.
100 degrees Celsius? No, exactly. The answer is correct, but you must need to mention 100 degrees Celsius at 1 atm, isn't it? Am I right?
Native. Yeah.
That's it. Okay. So 100 degrees Celsius at 1 atm, which means at an atmospheric pressure, the water should boil at 100 degrees Celsius. Okay. But you've been heard that if you go to higher altitude places, for example, like the Everest mountain or something, then you are boiling the water at the top of this mountain. The water will boil at readily at 77 degrees Celsius or 70 degrees Celsius even. Have you ever wondered that's what's the reason behind that? Because at higher altitudes there should be less pressure. Okay, so if the pressure is too low, that means the boiling point also should be altered. Okay, clear? So this is the basic concept of this boiling point to pressure itself. Is it clear, guys? Okay. Why I taken this class right now? Because next of all, we are going to studying about the refrigeration cycles. For that one, we must need to understand these kind of things. Now tell me, what is the process called where a liquid phase is converted to vapor phase? What is that process called? Tell me.
Vaporization.
Vaporization, exactly. Evaporation, vaporization, either you can call. Then what is the process? The phase change will happen from vapor to liquid. What is that?
Condensation.
Condensation, exactly. So condensation, vaporization. So once again, guys, one more thing. What is the process when a solid is directly converted to vapor? No idea? What is the process that we call a solid phase is directly converted to vapor phase? What is it? Sublimation. Did you remember? Sublimations.
Now remember even.
Yeah,
Yeah,
sublimation.
Ice.
Example is camphor, which is karpuram. Okay,
Mhm.
that's it. Because it's in a solid phase, while you heat up the thing, it should be readily goes or readily jumped over into a vapor phase itself, isn't it? There is no liquid phase changing, isn't it? That's it. So these are the basic scientific process that we need to study. That's it. Now we are going to studying about VAR cycle. What is it? VAR cycle, which is vapor absorption refrigeration. What is it? Vapor absorption refrigeration. So once again, guys, VAR is a refrigeration cycle, first of all. And this VAR cycle is much related to which word? It should be explained in something like, yeah, I will show a small block diagram, which is, should be related with this one itself. Yeah, I think it's visible right here itself, isn't it? You can see. So this is how how a VAR cycle works. So VAR stands for vapor absorption refrigeration cycle. All right, vapor absorption refrigeration cycle. So the process, you know the idea, isn't it? Which is heat transfer from low temperature region to high temperature region with the help of some external work. So that's what we are going to do right inside the VAR with the help of a VAR cycle itself. So let's get started. There are two type of VAR systems are there. The first one is NH3 H2O cycle and the other one is LIBR to H2O cycle. Okay. So first again, first one is NH3 H2O cycle. Okay. And the other one is LIBR H2O cycle. This is it. So these are the two different type of VAR cycle that we are mostly using right on our industry itself. So NH3 means what? It is meant to be ammonia and H2O means water, isn't it? That's it. And LIBR stands for lithium bromide and again H2O stands for water. So here now I'm going to explain the working of a NH3 water cycle based VAR cycle itself, okay? Or ammonia water based VAR cycle, okay? Can we start? So here we can see a various kind of components right inside the block diagram itself, isn't it? So the work should be started from the absorber itself, or the work should be started from the absorber. So inside the absorber, this is the portion where ammonia should be mixed along with water itself. All right. Is it clear? Is the beginning is clear, guys? Hello? Is it clear? Here, inside the absorber, initially, they will mix the ammonia right inside to the water itself. You know what? Ammonia is highly toxic, isn't it? Ammonia is highly toxic. But at the same time, it is ammonias are used for various application itself, isn't it? And ammonias are carried, or ammonia gas is carried in some kind of bullets. Bullets means what? That bullet trucks, that trucks, the big trucks which carries petroleum, this kind of ammonias, ethane, methane, propane, a lot of things, isn't it? So those bullets will carry this kind of ammonia. So if there is an accident happens, what happened? Eventually, the NH3 will vaporizes directly to the atmosphere itself, and it can cause some severe problems on that locality itself. So what they will simply do now, they will pour water along on the atmosphere itself. Why? Because ammonia is easily miscible in water itself, which means ammonia easily bonded with water. Okay, so that's why we are also using ammonia H2O cyclase to be a VAR refrigerant right here itself. So in here, inside the absorber, initially, the ammonia is mixed with water. So as we studied that the boiling point of water is 100 degrees Celsius at 1 atm, whereas the boiling point of ammonia is minus 33 degrees Celsius. That means if you take out ammonia from its container, what will happen? It will be readily vaporizes. That's it. So here, a small problem will rise. When we mix this ammonia with the normal water, which means the room conditioned water or room temperature water, what will happen? While through this mixing, a lot of heat should be dissipated during that process itself. Am I clear? That means when ammonia is mixed along with the water, it creates more heat dissipation across the absorber chamber itself, which results in the higher temperature of water. That means it can brought the temperature of water to a certain levels. So we don't want to rise the water temperature right there. That's why we are providing some kind of cooling water in order to maintain the absorber temperature into a certain limit itself. All right. Is it clear, guys?
It's clear.
Okay. So deliberately here, once this ammonia is mixed with this water, now it became the strong solution. What is it? Strong solution. So ammonia plus water is termed as the strong solution. And this strong solution is carried over to generator with the help of a transfer pump. Okay. With the help of a pump, these strong solution should be supplied over to a generator. So here, let's consider generator as to be a chamber, a big chamber. So inside this generator, we bumped into the entire strong solution into the generator itself, isn't it? Actually, inside this generator, we can see some kind of heating coils. What is it? Some kind of heating coil. I'm bad at drawing, guys, actually. Okay, so this is meant to be the heating coils. Okay, this is meant to be the heating coil. So the main advantage of this VAR cycle is nothing but it is the generator. Okay, the heating coil is can either connected with a conventional energy itself. So what do you mean by conventional energy? In the petroleum manufacturing industries or this rigs, while the fractionating happens, a lot of energy should be deliberately liberated to atmosphere itself, isn't it? And these energies will have high temperatures. For example, if you just consider these boiler plants, inside the boiler plants, they will use water or the steam, isn't it? They will convert the water into steam, even to superheated steams. So once these superheated steams are rotated by the turbines, or sorry, these superheated steam should be subjected to rotate the turbines, and later this steam should be carried again to the boiler, and some of the steam should be rejected to the outside itself. You know, we've been seeing this cooling towers, isn't it? So in those areas, if you are subjecting or if you're wasting those energy, you can admit that energy directly into this heating coil, which is placed right inside the generator itself. That means what? You know, this is a coil, so the heat should be transferred across this coil itself. At the same time, once this strong solution reaches the generator, ammonia will readily vaporizes right inside the generator chamber itself. Is it clear? Because you know, it will exceed its boiling point and it will become a superheated stage right there itself. Am I clear, guys? Hello? I know it's a bit hard to understand. Avinash, മനസ്സിലായോ? Avinash and others. ഇതുവരെ പറഞ്ഞത് മനസ്സിലായോ? Shamir and മനസ്സിലായോ ഷമീറെ? Yes. Hello? എന്താ മട്ടിരിക്കുവാണോ? Hello? மீதி இருக்கிறவங்களுக்கு புரிஞ்சுதா? Like Jason and these guys, little confused. What is the confusion, guy? Tell me. Come on, we need to clear this one. Go on with doubts in the chat session itself. Okay, നിങ്ങൾക്ക് clear ആയി. Okay, what is the doubt, Avinash? Tell me. How this heat is came, isn't it? That's what you doubt? ഇത്രയേ ഉള്ളൂ അവിനാശ്. ഇത്രയേ ഉള്ളൂ. അതായത് ഈ ഹീറ്റ് എന്ന് പറയുന്നത് നമ്മുടെ ബോയിലറിൽ നിന്നൊക്കെ ഒരുപാട് വേസ്റ്റ് എനർജി ഒരു പുറത്തോട്ട് തള്ളും, ഈ നദിയിലോട്ടൊക്കെ ഒഴിച്ചു കളയുമാര്. അപ്പം ആ ചൂടുവെള്ളം ആയിക്കോട്ടെ, സ്റ്റീം ആയിക്കോട്ടെ, എന്തോ ആയിക്കോട്ടെ, നമുക്കിവിടെ ഒരു ചെറിയൊരു എനർജി വേണം നമുക്ക്. എന്തിനാ? അമോണിയാനൊന്ന് ചൂട് പിടിപ്പിക്കാൻ. സോ ഓൾമോസ്റ്റ് അമോണിയ ഈസ് മിക്സ്ഡ് അപ്പ് വിത്ത് വാട്ടർ ഇറ്റ്സെൽഫ്, ഇസ്ന്റ് ഇറ്റ്? സോ ഈ കോയിലില് നമ്മളെ വീട്ടിൽ വെള്ളം ചൂടാക്കാൻ വെക്കത്തില്ലേ, അതുപോലെ തന്നെ ആ ചേമ്പറിനകത്തോട്ട് നമ്മൾ ഈ കോയിൽ അങ്ങ് ഇറക്കി വെച്ചേക്കുക, ഈ ഹീറ്റിംഗ് കോയിൽ. സോ ഈ അമോണിയ എപ്പം ഈ ജനറേറ്ററിനകത്തുള്ള ഹീറ്റിംഗ് കോയിലായിട്ട് കോണ്ടാക്ട് ആകുന്നു, അപ്പൊ തന്നെ 11 വേപ്പർ ആകും. അറ്റ് ദ സെയിം ടൈം ഈ വേപ്പറിന്റെ ഫേസ് കുറച്ചും കൂടി അങ്ങ് പോകും, വിച്ച് മീൻസ് ഇറ്റ് വിൽ ഗോ ടു, യു ബീൻ സ്റ്റഡീഡ് അബൌട്ട് വെറ്റ് സ്റ്റീം, ഡ്രൈ സ്റ്റീം, ദെൻ സൂപ്പർ ഹീറ്റഡ് സ്റ്റീം, isn't it? അതുപോലെ തന്നെയാണ് ഈ വേപ്പേഴ്സും. ഇവിടെ അമോണിയ ഇനീഷ്യലി വിൽ ഗോ ടു ലൈക്ക് wet ammonia vapor and dry ammonia vapor and superheated ammonia vapor. So typically we will be getting something like dry or superheated. Okay, മനസ്സിലായോ നിങ്ങൾക്ക് അവിനാശ്? അതാണ് ഞാൻ ലാസ്റ്റ് പറഞ്ഞ പോയിന്റ്. ഓക്കെ, ക്ലിയർ ആണോ? ഷമീറിന് മനസ്സിലായോ? ഷമീർ ആൻഡ് മാം, ഇസ് ഇറ്റ് ക്ലിയർ? അല്ല ക്ലിയർ അല്ല, ഞാൻ പറയുന്നത് എടുക്കുന്നത് മനസ്സിലാവുന്നുണ്ടോ? കമ്മ്യൂണിക്കേഷൻസ് ഓക്കെ അല്ലേ? വീണ്ടും ലാസ്റ്റ് പോർഷൻ പറയണോ? അല്ല, ഓക്കെ, മനസ്സിലായി. ഓക്കെ, ഫൈൻ. അവിനാശിന് മനസ്സിലായോ? അവിനാശ് ഇല്ലെങ്കിൽ ഇല്ലാന്ന് പറഞ്ഞോ, കുഴപ്പമില്ല. വൺസ് അഗൈൻ ഐ വിൽ എക്സ്പ്ലെയിൻ.
Okay, sir.
ഓക്കെ, ഫൈൻ. மீதி இருக்கிறவங்களுக்கு புரிஞ்சுதா? ஷஃபீக் and ஷாஹுல், ஷண்முக செல்வன் and is it clear? Okay, fine. That's it. So now we got the ammonia vapor at the top side of this chamber right there itself. Okay, but here there is a high chance of water. It can also convert to vapor itself. That means due to the high temperature right inside the generator, there may be a chance of water is getting evaporated. That's why we are provided a certain attachment along with the generator, which is named as analyzer. What is it? Analyzer. The purpose of analyzer, this analyzer will only allow ammonia vapor to the other side. And if any water vapor formation happen, it should be again condensed back and drop down to the generator chamber itself. Clear? That means the purpose here, it's only about the ammonia. We don't water from further now on itself. Clear? Is it okay? புரிஞ்சுதா உங்களுக்கு? Clear? So you will be having an analyzer. The purpose of analyzer is to only allow the ammonia vapor to the other side itself. Clear? Now this ammonia vapor will be having high pressure and high temperature, isn't it? I told you the superheated steam or superheated stages. That means it's constraining a lot of pressure right inside the vapor phase itself. That is meant to be, it is the till level or we can say the last stable level of that vapor phase itself. So we are subjected ammonia to that extent itself. All right. That means now this ammonia having high pressure and high temperature right inside him itself. Isn't it clear? Then the next destination is condenser. So condenser meant to be what? As the name implies, there should be a condensation process will takes place. For that one, we need an heat exchanger, HX. That's it. So heat exchanger, we can study the types of heat exchangers later. So here, we will be using a cooling water, which should be taken from the lakes, rivers, or wherever from the cooling towers. Either you can take that cooling water. So what happened? You know, for example, if you are buying a cold water bottle and you are placing right inside your room itself, after some times you can see some kind of water droplets present at the outer surface of the water bottle itself. Actually, what happens is the water right inside the bottle pumped up to the outside of the bottle itself? No, isn't it? Actually, the process right happened there itself is the condensation of moisture content right inside the air, isn't it? That's what happened there itself. So similarly, here also, as the high pressure and high temperature ammonia vapor is subjected to the condenser side, what happened? The temperature will be started to drop down. Okay? Is it clear? Hello? Is my point is clear, guys?
Temperature will drop.
No, not
The
the
heat
pressure.
temperature.
So, exactly. Temperature of the ammonia vapor will be dropped, but not the pressure. Note down the point. I told you pressure proportional to T, not T proportional to P, isn't it? That means when the temperature throttle down, that doesn't mean the pressure will go downwards, isn't it? Okay. Clear, guys? All right. So that's the purpose. Sorry, that's the working that should be happening right inside the condenser itself. Now, once these ammonia vapor is converted into liquid ammonia, what is it? Liquid ammonia. Am I clear? So once this condenser is crossed, that means after completing this condenser side, the outletting ammonia is now in a liquid phase itself. In which phase? A liquid phase. So this is a process. It's somehow something like this. You know, for example, you are boiling water at 100 degrees Celsius and it's converted into water vapor itself and even to steam. And you are again cooling the steam with the help of some medium and you brought back the steam into water vapor, sorry, water droplets. Now the water temperature will be around like 30 degrees Celsius or 20 degrees Celsius. No, isn't it? It will not go to that extent itself. It should be just drop down to a little bit. That means if it is in 100 or 100 degrees Celsius or 110 degree water vapor is converted to a 95 or 96 degrees Celsius of water droplets itself. That means only a small temperature change will happen in order to initiate the phase change. That's the point. Clear? Hello? நான் சொல்றது புரியுதா உங்களுக்கு? இந்த கண்டென்சர் பக்கம் நடக்கிற ப்ராசஸ் இவ்வளவுதான். டெம்பரேச்சரை ஜஸ்ட் த்ராட்டில் டவுன் பண்ணி அதோடைய ஃபேஸ் சேஞ்ச் இனிஷியேட் பண்றதுக்காக தான் நம்ம கண்டென்சர்ல அதை அலோகேட் பண்றோம். கண்டென்சர்ல நம்ம அதை கொடுக்குறோம். புரியுதா உங்களுக்கு நான் சொல்றது? நம்ம கிளியர்? ஓகே தானே? சொல்றது புரிஞ்சுதா? ஹலோ
Sir, once again, it's clear, but just once again. Throttle down temperature.
ஓகே, நான் சொல்றேன் எவ்வளவுதான். அதாவது கண்டென்சருடைய பர்பஸ் என்னன்னா கண்டென்சேஷன் நடக்க வைக்கணும், அல்லாம ப்ரெஷர் டிராப் பண்றது கிடையாது. அப்போ இங்க டிராப் ஆகுறது என்னதுதான்? டெம்பரேச்சர் தான் டிராப் ஆகும், நாட் த ப்ரெஷர். ஓகேங்களா? தென் இஃப் யூ ஸ்டடி மச் மோர் டீப்பர் ஹியர், அந்த ஹை வேப்பர்ல இருக்கிற அந்த அமோனியாவை, அதாவது சூப்பர் ஹீட்டட் வேப்பர், நான் சொன்னேனே இப்ப இந்த டெம்பரேச்சர் எல்லாம் ஒரு 150 டிகிரி ஸ்டீமா இருக்குன்னு வச்சுக்கோங்களேன். அந்த 150 நீங்க 98 95 கொண்டு வர்றீங்க. அதாவது அது என்ன ஃபேஸ்ல இருக்கும்? இப்போ லிக்விட் ஃபேஸ்ல இருக்கும். நாட் சீயிங் அபவுட் அமோனியா, சீயிங் அபவுட் வாட்டர் வேப்பர். ஓகே, புரியுதா நான் சொல்றது உங்களுக்கு? அங்க இருக்கிறவனை புடிச்சு திருப்பி அவனை ஜஸ்ட் ஃபேஸ் சேஞ்ச் பண்ண வைக்கணும். அதுக்காக தான் கண்டென்சர்ல விடுறோம். புரிஞ்சுதா? Okay. For my Mallu friends, is it clear? Who is that? Yeah, like Shamir and Bakilar Consulai, Avinash Consulai. Okay, le. Shamir and ma'am, is it clear? Okay, fine, guys. Okay, so simply the purpose of this condenser is to just to brought back that temperature to initiate the phase change. That's it. All right. Now we will be getting a high pressure, medium temperature ammonia liquid, isn't it? That means after completing this condenser, we will be getting a high pressure, medium temperature liquid ammonia, and it should be collected by this kind of receivers, which should be connected at the end of this condenser. Then next of all, it should be provided to the expansion valve. So as the name implies, expansion. So expansion means what? That symbolically means high volume, isn't it? That's what it means, isn't it? High volume means, so if the volume is too high, what will happen? If the volume increases, what will happen?
More space is required.
That means what?
Expansion is required.
Expansion will happen. That means
Pressure
what?
drop.
Pressure drop. Exactly. That's it. That's the point you need to tell. So once the volume, so in all scenarios, it's not about the volume. Okay. Once again, always the expansion valve doesn't mean to be like a volume based aspect. Maybe it can change, whatever. So in here, the volume will be increases, which will result in the reduction of pressure. That means now this high pressure should be throttled down to low pressures. Okay. So this low pressure, as if the pressure decreases, what I told you, temperature also will be dropped down, isn't it? The temperature will be also dropped down into negative levels. I hope for ammonia, it will go beyond like -40 itself. Okay. That means the ammonia temperature will be readily go to negative levels after completing this expansion valve. Now we will be getting a low pressure, a low temperature, still in liquid. It's not get solidified. Why? Because the freezing point of ammonia is large much. Okay. So after crossing this expansion valve, now this high pressure, medium temperature liquid ammonia become low pressure, low temperature liquid ammonia. Clear? And this liquid ammonia should be carried over to the evaporator, and these evaporator are placed right inside the room where you need the cooling effect. Is it clear? Is it clear, guys? Okay, now. So what will happen? Once the liquid ammonia is passed over to the evaporator coil, a small heat exchange will take place between the room air and to the coil, evaporator coil. That means gradually the temperature of the ammonia started to increase, and it can reach the boiling point at this low pressure itself. I told you guys, at low pressures, boiling point also should be throttled down, isn't it? I told for 1 atm pressure, the boiling point is -30. But if the pressure is too low, what will happen? The boiling point also will be throttled down. So that means after crossing the evaporator, probably the ammonia should be in vapor phase itself. Clear? That means low pressure vapor. That's the difference, not the high pressure vapor. So after crossing over the evaporator, due to the heat exchange between the room air and the coils, the temperature of ammonia will be again rises, and which will result in the formation of vapor, and this vapor will be again admitted over to the absorber. And now what will happen? Again, this water should be mixed over with the ammonia vapor. Again, it should be ready for the next cycle. At the same time, from the generator, the water is still there, isn't it? The one who carried this ammonia is still right there in the generator, isn't it? That should be brought back again to the absorber with the help of a pressure reducing valve. What is it? This is a pressure reducing valve. So that's why the return water is termed as to be weak solution. Clear? മനസ്സിലായോ മക്കളെ? Okay, புரிஞ்சுதா உங்களுக்கு நான் சொல்றது? Hello, once again, any doubts? Hello, okay le?
സാറേ evaporator ന്ന് എയർ കണ്ടീഷനിങ് എങ്ങനെയാണെന്ന് ഒന്ന്
മനസ്സിലായില്ല. എന്തോന്ന് എന്തോ മോനെ മനസ്സിലാക്കി കേട്ടില്ല.
evaporator ൽ നടക്കുന്ന പ്രോസസ് ഒന്നുകൂടെ പറഞ്ഞു.
Okay. So in evaporator, guys, actually evaporator means what? It should be placed inside the rooms or the area where you need to provide the cooled air, isn't it? Because after expansion valve, the ammonia temperature is dropped down to too much negative levels. I told you, isn't it? So here, the room air should be getting contacted with the evaporator coil. അവിനാശം മനസ്സിലാവുന്നുണ്ടോ? അതായത് റൂമിലെ എയർ ആയിരിക്കും നമ്മുടെ ഇവാപറേറ്റർ കോയിലായിട്ട് കോൺടാക്ട് ചെയ്യുന്നത്. അപ്പൊ എന്ത് പറ്റും? റൂമിലിരിക്കുന്ന എയറിന്റെ ടെമ്പറേച്ചർ ആർ അബ്സോർബ് ചെയ്യും, അല്ലെങ്കിൽ ഹീറ്റ് ആർ അബ്സോർബ് ചെയ്യും? ഇവാപറേറ്റർ കോയിലകത്തിരിക്കുന്ന അമോണിയ അബ്സോർബ് ചെയ്യും. അമോണിയയുടെ ഹീറ്റ് എങ്ങോട്ട് പോകും? റൂമിലോട്ട് പോകും. മനസ്സിലായോ? ഇതാണ് ആ ഹീറ്റ് എക്സ്ചേഞ്ച് പ്രോസസ്. വി ക്യാൻ ഡിഗ് ഓൺ ദിസ് തിങ് ഇൻ ദ അപ്കമിംഗ് ക്ലാസ് വൺസ് അഗെയിൻ. ഓക്കെ, ഞാൻ പറഞ്ഞ മനസ്സിലാവുന്നുണ്ടോ നിങ്ങൾക്ക്? അവിനാശെ, ക്ലിയർ ആണോ?
ഓക്കെ സാർ.
ഒന്നുകൂടി ഞാൻ പറയാം, BCR സൈക്കിൾ ഒന്നുകൂടി ഞാൻ പറയാം, മനസ്സിലാവുന്നത് ക്ലിയർ ആയിട്ട് എങ്ങനെ നടക്കുന്നത്. So is there any doubts rather than this one? Any other doubts? Sachin, is it clear? Okay, fine. Weak solution, it's nothing ma. We just carried this ammonia along with the water right inside the generator. Till that time they are like some kind of couples, but after ammonia getting vaporized, the water should be still hold back right inside the generator itself, isn't it? So what will happen? It will be eventually supplied again to the absorber itself. That's why it helps also. Sorry, the cooling coil that we are provided right inside the absorber, it's also provide coolness, which means it will also absorb the temperature of water, which should be brought back from the generator, and it should be absorbed by this cooling water that will be supplied alongside the absorber itself. Clear? Is it clear, guys? Very simple. Weak solution means the only water should be comes from the generator after passing over to the ammonia vapor itself. പുരിയുതാ உங்களுக்கு நான் சொல்றது? ഷമീർ, ഇത്രേ ഉള്ളൂ. വീക്ക് സൊല്യൂഷൻ എന്ന് വെച്ച് കഴിഞ്ഞാൽ ജനറേറ്ററിൽ നിന്ന് തിരിച്ചു വരുന്ന വെള്ളം. അപ്പം ഫോർ ദാറ്റ് വൺ വി നീഡ് സം കൈൻഡ് ഓഫ് പ്രഷർ റെഡ്യൂസിങ് വാൽവ്. കാരണം അതിന് ടെമ്പറേച്ചർ ഒരുപാടുണ്ടല്ലോ. ജനറേറ്റർ ചേംബറിലെ ടെമ്പറേച്ചർ ആയിരിക്കുമല്ലോ ആ വെള്ളത്തിനും. അപ്പം വെള്ളത്തിന് നമ്മളൊന്ന് കൂൾ ചെയ്യണ്ടേ? അതിനും കൂടിയാണ് താഴെ ഇരിക്കുന്ന ഈ കൂളിംഗ് കോയിൽ. മനസ്സിലായോ? ഫോർ അതേഴ്സ് ഇസ് ഇറ്റ് ക്ലിയർ? ഓക്കെ, all right guys. Okay, that's it. So this is one type of vapor absorption cycle itself. Okay, meant to be ammonia water cycle. Normally ammonia based VAR cycles are used for cold room application. For example, this kind of meat storage factories, dairy processing units, and especially these kind of areas, they will be using this kind of ammonia based water cycle absorption refrigeration cycles. And the main advantage of this VAR cycle is the lesser power consumption. So I will explain why we will be facing this lesser power consumption by implementing this kind of VAR cycle after we completing the VCR cycle. Okay, now clear? Then once again, as in the case of LIBR H2O cycle, it's like vice versa. Here the entire work is done by ammonia, isn't it? But in this case, the entire work should be done by water itself. That means it should be a medium temperature process itself. Why? Because if you drop the pressure too much, what will happen? Water will be freezed out, because the freezing point of water is 0 degrees Celsius, isn't it? So what will happen? Blockages will be happen right inside the pipeline itself. Okay, is it clear? All right. So normally LIBR water cycle based VRs are used for medium temperature application, like 5 degree supply, 6 degree supply. In those areas, we will be using this kind of LIBR and H2O cycles. All right. So is there any doubts, guys? No, isn't it? Okay, then. All right. So I think it's enough for today. So tomorrow we will be continuing with the remaining sessions. So just go through this class once again. If you're having any doubts, just let me know. Okay, now. All right, guys, you can leave.